But you got 1, 0, 0, 7, 0, 1, 0, 1, 0, 0, 1, 3. But the answer is what you said, right? The answer you would put in your blank is parentheses 7, 1, 3. Word-wise, I like area codes. If you got decimals, then you did something wrong. Then you input wrong.
I still got 7 point something.
You got close, but you got wrong. And it's when you go back and you look, it's going to be something minor, like you put a 7 in instead of an 8 or something like that. Or maybe you put 85 instead of 81, like I tried to. What was it?
Yeah, I did 85 instead of 81.
I'd written that at first to your credit. I changed it. Anyone else not get it? What? You changed it to an 81? What?
Why was it that close?
Oh, because those were close-ish. Everyone else got 713? Okay. All right. Area codes are an easy three-number pairing, three-number grouping to come up with. That's convenient. So, you know, 976 and okay. Do you think if we added on a fourth variable and a fourth equation that would be tremendously trickier for you? I don't think it would be, and I don't know that it's really worth the time to just punch numbers, a bunch of numbers. Because it's the same process. You put in the 4x5 matrix, you row reduce it, that last column, hopefully, it is your solution, and you put them in that order, 7, 1, 3. If I would have said this, would that have been correct? Would that have gotten any credit on your test? Okay. All right. So don't monkey up the order at all, please. So let's talk special cases. Remember, not every system of equation has a nice solution. Sometimes you got no solution. Sometimes you got infinitely many solutions, correct? Okay. So if you're doing this RREF business, how do you know if you've gotten no solution, or how do you know if you've gotten infinitely many? All right. It's easy enough. Okay. Suppose you've put in this augmented matrix, and you've done your RREF business. But instead of getting like all the normal ones and zeros that you're used to getting, what if you've gotten something like this? Why is that problematic? What does that bottom row say? 0x's plus 0y's equals 0 plus 0 equals 1. So when you see something like that, that's a no solution. Okay? Even if you had a 3x4 matrix, if you did your RREF business, you know, you got your 1, 0 and your 0, 1 there, and they're like you were expecting. But then, is this too much in the way? Okay. If you gotten this, that's not something good. But maybe this was like a -3, and maybe this was a 1/3, and this was a 0, 0, 0, and here you had 0, 0, 1. That's still the same problem, right? So basically, if your bottom line is all zeros except the last number is a 1, or any other number besides 0 for that matter, although it's going to be a 1 the way the calculator does this, that's your no solution case.
And it's always at the bottom?
Yes. Now, it's even possible you could have a couple of these at the bottom, but that's unlikely. Alright? Now what about infinitely many solutions? Remember those dependent systems? They're similar, except this time you get something like 1, 2, and maybe this is a -4, but this is 0, 0, 0. In this case, it's not no solution because that bottom line isn't a contradiction. but you end up with still an infinite number of solutions, an infinite number of pairings of x's and y's that would satisfy this guy up here. Okay? But if you see a bottom row that is strictly all zeros, then on the test, all you're going to need to say is how many solutions. Okay? Even if it was a 3 by 4 or 4 by 5, if you had a bottom row that was all zeros after RREFing, right? Okay, something like this. Okay. Now, I'm satisfied with that answer on the test, but your homework won't be. Your homework wants to take it to the next step. So we need to talk about that.